So, hello everyone and welcome to this Men&Mice webinar. This webinar is focused on, well, the ring that rules them all. Is it, Karsten? So with me today I have Karsten Strodman. Karsten, you can maybe introduce yourself.
Yes, hello, I'm Karsten here from the Men&Mice services team, and yes, it's kind of the ring that rules them all. We talk about the rolling of the Internet DNSSEC trust anchor.
Very good. But please note, all attendees, that you're on mute, but we encourage you to submit your questions at any time through this GoToMeeting webinar, through the GoToMeeting control panel. And we're also recording this session, so you can find this webinar along with the slides and recording from previous webinars. You can find all of this at our website. It will take a few days for us to put this webinar there. So, but so if you drop off or anything, you can pick up where you left there. But Karsten, are you ready?
Yes, I'm ready.
Then the audience is yours.
Thank you, Peter. Hello, everybody. Today we have an important topic that will become will happen in this summer, and everyone operating a DNS resolver should be aware of this. It's the rolling of the Internet's DNSSEC trust anchor. So first we will talk about what is the Internet trust anchor and why does that trust anchor or the KSK being rolled, being changed, and why now? And what is the actual timeline? When does what happened? And in order to make that as smooth as possible, the people that designed the DNS protocols, they have prepared for this event, and they have built in a protocol into all DNS servers that will allow this trust anchor to update automatically. And we talk about how that is supposed to work and what can fail. And then we talk about the common DNS resolvers, popular DNS resolvers, namely Bind 9 and Unbound and the Windows DNS resolver, and where, as an administrator, you can check if you have the new trust anchor, and where you maybe can configure the trust anchor yourself in case the automatic update doesn't work. So what is the Internet's DNSSEC trust anchor? Now, the DNS root zone, which is the start of all delegation in DNS, is DNSSEC secured. And the same is true for many top-level domains and second-level domains. Now, DNSSEC data, no matter on what level, is usually validated against a trust chain. That is, there's a chain from the domain name and the data you receive to the parent zone, to the parent zone of the parent zone, and ultimately to the root zone. And while it is possible to have trust anchors for the top-level domain or second-level domains, usually we use a trust anchor for the root zone. And that trust anchor is configured in the DNS resolvers. That is, if you have a Bind 9 running in resolver mode as a caching DNS server, or if you have Unbound or Microsoft DNS or not, or Power DNS or anything else that is a resolver and can do DNSSEC like DNS mask, it has a trust anchor configured. So usually we use the root zone's trust anchor because that is the trust anchor, as Peter called it, that rules them all. That is the trust anchor where you can validate all the DNSSEC signed data in the internet. Now, it is possible to have also trust anchors for some domains under the root zone, like for top-level domain or second-level domain. Most people most administrators just have the root trust anchor configured in their DNS server. So let's have a quick look on how DNSSEC name resolution works. Here, the client machine in the middle, on below, there the user starts a web browser and goes to www.example.org. A DNS request for that domain name goes out to the validating DNS server. That is the resolver. That is the one having the trust anchor. And normal DNS resolution goes top down the DNS resolver, having nothing in the cache at the moment, goes to the root name server, gets a so-called referral back, referring the caching server to the org servers. Then it will ask the org servers for the same question: what is the address of example.org? Another referral comes back. Here are the example.org servers, and then the request is sent to example.org. Now, because it's a DNSSEC enabled resolver in this case, it sends the DO flag, the DNSSEC OK flag. And that means that the example.org authoritative DNS server sends back the data being requested, the A record, the IPv4 address, plus a signature as a resource record set with the signature. Now that data is now stored and needs to be validated, meaning we need to make sure that the signature under this IPv4 address is actually valid, it's good. In order to do that, caching server resolver fetches the public key of the zone that has created the signature, which is in this case is example.org. We get the signature back. We get the public key back, and we get that also signed with the so-called key signing key. And now we need to make sure that the key signing key of example.org has not been tampered with. It's still the original one. So for that, we go to the parent domain, which in this case is org, and we ask for this delegation signer record of example.org, which holds a hash of the public key signing key of example.org below. Now that comes back, that itself has a signature, and it has a signature from org. In order to validate that signature, we need the public key of org. We fetch that from a DNS key record. That comes back, and now we need to check whether the public key for org is good. For that, we go to the root zone. We ask for the delegation signer that contains the hash of the org's DNS key. And it's coming back with a signature. In order to validate the signature from the root zone, we need to have the public key of the root zone. That comes back, and now we have no way to validate the key, the public key of the root zone, because there is no parent. There's nothing above the root. So in this case, there must be something locally configured, and that is a trust anchor. And that is actually what will change. So in this case, our resolver looks for a trust anchor in the configuration file for the root zone. It fetches that, and now it can validate all the data, starting from the signature of the root zone all the way up to the IPv4 address being received. And if all is good, if every step is successful in the validations, then the answer is being sent to the client, and the authenticated data or authentic data flag is being set in the response, and the client can be fairly sure that this data is correct and not spoofed. And the data loads. So what will now change? The public key in the root zone, so-called the key signing key, will change, and because that is changing, also the trust anchors in all the resolvers that do DNSSEC validation must also change. So why do we do this? I mean, it sounds like a stuff that well, can go wrong, and yes, there are possibilities why this can go wrong. And why not just keep it? Why not? Why change running system? It's working now. Now, changing or rolling such a cryptographic key like the DNSSEC key of the root zone is good security practice, because keys can be stolen, and that can go unnoticed. Now, for the root zone, that is highly unlikely because they have very good security there, but nevertheless, could happen. But also, keys can be broken. Now the key signing key of the root zone is a 2048-bit RSA key. That's a strong key. And on average, that takes a long time, multiple hundred years with modern computing power to break such a key, on average. But someone could be lucky. Someone could just start and have the key broken tomorrow. It's very, very unlikely, but it could happen. And the longer a key is actually being used, the higher is the chance that such a lucky event happens. Still very unlikely, but therefore it's a good practice to roll the key. Now the current key signing key being used in the root zone has been introduced in the summer of 2010. That was 7 years ago. The original plan was to roll the key every 5 years. Now it took a little longer this time because it's the first time, and people needed to figure out, ICANN needed to figure out how to best do such a key rollover, because nobody has done that before, not at the scale of the internet. And there's a lot at stake. If there's a operational mistake while rolling the key on the root zone, that can shut down the internet for a whole lot of people. So it is the first time that this key signing key roll and the trust anchor roll will be done for the internet, and it will start this summer. By the way, the root zone also has a zone signing key. It's also so-called ZSK, and that is rolled periodically. That is like 3 or 4 times a year, and that is rolling without an issue. But the zone signing key has no dependency on the trust anchor. So changing the zone signing key is just something that ICANN can do for the root zone whenever they like. This time is special because when the key signing key rolls, also the trust anchors in the resolvers must change. So if the trust anchor that is configured in the resolvers doesn't match to the signatures created in the root zone, that will break DNS name resolution, and that will break it completely. Yeah, if that happens and you dig for facebook.com or ic.org or men&mice.com or whatever your favorite website is, you will get a server fail, and your browser will not be able to view the website. But wait, facebook.com is not DNSSEC signed. Why should it then fail? Now, the answer here is that yes, it's true that facebook.com is not DNSSEC secured, but the root zone is, and the com zone is. And if we use a DNS resolver that doesn't have a matching trust anchor, then the delegation from the root zone to com and from com to facebook.com will fail. So even though facebook.com on itself will be completely fine, the way to find facebook.com will be broken. So for the end user, the effect is the same. They cannot go to Facebook or whatever website because everything starts at the root zone. And if the validation of the root zone is broken, everything is broken. So you might now say, I don't use DNSSEC validation in my resolvers. This will not impact me, right? Not quite. Of course, there's less that can go wrong in your case, but still there will be a time in September this year, we come to the exact date later in this webinar, and that same event will happen later in either November or December, I'm not 100% sure, when there will be 2 key signing keys and 2 zone signing keys in the root zone, and that will make the DNS answers from the root zone quite larger than normally. And that can even impact DNS resolvers that don't validate DNSSEC themselves, but they might have an upstream resolver that do validate, and that can go into trouble because the answer packages will be so big that there is a danger of fragmentation. And for example, if there is a firewall problem with the fragmentation, then the DNS might stop working. So here's the timeline, what will happen this year. It all started in October last year when the new key signing key has been created. And then 11th of July this year, the new key signing key will be published in the root zone. Now, at that point of time, the new zone will just be published. It will not be active, meaning it will not be used to create signatures. The old key signing key, the key signing key that we have today, will still be the active one and will still be used to create the signatures. But from that date on, DNS resolvers can start updating their trust anchors automatically. Then on the 19th of September, we will see a zone signing key role that will start in addition to the already running key signing key role, and that will create 4 public keys in the root zone, and that create large responses from the root zone. Now, tests have been made about this, and people are very sure that nothing really bad will happen, but there is a small chance if there is a problem with certain MTU sizes in your network that can impact your DNS name resolution at that point of time. So better to be aware as a DNS administrator that 19th of September something could happen, and I wouldn't start a vacation or start a different project at that date. Then the next important date is 11th of October. At that point of time, the new key signing key will be active, meaning that the new key will be used to create the signatures. And now all the DNS resolvers that haven't been able to get the new trust anchor in time will fail to validate the root zone. So there's time between the 11th of July and the 11th of October to get the trust anchor right. And how DNS resolvers do that automatically, are supposed to do that automatically, we will see in a moment. But as an administrator, you should check your DNS resolvers before 11th of October, possibly at the end of September, if the resolver had been able to fetch the current or the new trust anchor for the new key signing key. Then on January 2018, 11th again, the old key signing key will be marked as revoked, and so DNS resolvers can automatically remove the old trust anchor from their configuration. And then on the 22nd of March next year, the old key signing key will be completely removed from the root zone. And that concludes then the rollover. So the protocol to update the trust anchor is specified in RC 5011. And this RC 5011 protocol is one of 3 ways to get the new trust anchor in a DNS resolver. One way is to use manual configuration, that is, open the configuration file and write the new trust anchor in the configuration file. Now, that is the last resort, and it's not recommended because it's a static configuration and will probably get you problems on the next key signing key rollovers, because then you need to touch your configuration again. But if the automatic way fails, that's a good way to make sure that your DNS resolvers still work after 11th of October. You can also get the new trust anchor with the software update. So if you install the latest bind or latest Unbound software, it comes with the new trust anchor already baked in the software. Or, and that is the preferred way, the automatic trust anchor update with the RC 5011 protocol works. So here's the link to the RC. If you want to know the details, you can go there and read the RC. So I've tried to explain what RC 5011 is doing here in a graphical way. So on this slide, we have the root zone, one of the root zone's DNS servers on the top, which currently has the current key signing key. And we have on the bottom a DNS resolver, which has currently a trust anchor for the same key. Now you can identify the key by its key ID, which is 19,036 in this case, which is the old key signing key. So there we have the key signing key, and that is the trust anchor, and both should have the same number. Beginning on 11th of July, the new key signing key will appear in the root zone. And the key ID number is 20,326. And that is the new key signing key. And at that point of time, resolvers can start to download and automatically update the trust anchor. Both the old key signing key and the new key signing key are being signed with the old key signing key. Now, a DNS resolver will request from time to time, periodically, the DNS key record set from the root zone. It will receive that record set containing both the old and the new and the signature. Now the resolver can validate that answer with the existing trust anchor, because the signature is being done with the key 19,036 and the trust anchor is for 19,036. We can validate the signature with the existing trust anchor. And now we configure the new trust anchor for that new key in our configuration file, but at this point it's not active, it's inactive. Because we have now to wait 30 days, and during the 30 days the DNS resolver will constantly check, like once a week or so, whether the same new key appears in the root zone. Now this is a safeguard against spoofing that might happen or attacks that might happen. With this, a DNS resolver must see the new key for a period of 30 days uninterrupted in order to be sure that the new key is really a valid key. That also means that if your DNS resolver goes offline in July, or goes offline or is not online 30 days in a row between July and October, it might not be able to finish the automatic trust anchor rollover. So mid-August, if our resolver was online all the way from July to August, we now request the DNS key again. It's still the same key set, and now we can be sure that the new trust anchor, the new key, is really the valid one, and now that one becomes active. The old one is still in there, and now we have two trust anchors, so we can validate signatures that are created by either key. We can validate signatures from the old key, and we can also validate signatures coming from the new key. On October 11th, the key signing key roll in the root zone will happen, meaning that the signature on the root DNS key set will be created by the new key. So this now has the key tag 20,326. And that is being then validated with the new trust anchor, which hopefully is on the DNS resolver now. On January 2018, the old key signing key is being revoked, and it gets a different flag. The revoke bit is being set on the flag field. So the DNS resolver knows that it can now remove the old trust anchor. And then on 22nd of March 2018, the old key is completely removed from the root zone. Nothing needs to be changed on the DNS resolver at this point, because the trust anchor rollover is already done at that point. So, how does it work with the different popular DNS resolvers out there? With bind 9, there's a file called managedkeys.bind, and that file contains all the trust anchors. It can contain multiple trust anchors, and currently it only contains the trust anchor for the current root key signing key, the 19,036 ID. That key, that file is being stored in the bind home directory. And that can be different depending on your installation. Usually it's something like var named or var bind or var cache bind. But if you search your server for manage.-keys.bind, you'll find that file. It's just a text file. You can go in there with an editor, but don't make changes with it. Just look at it. The latest bind 9 releases, namely bind 9.11.1 and 9.10.5, they contain the new key signing key trust anchor built in. So if you update your bind installation to either of these new versions or any version after that, you already get the new trust anchor and you are done. There's no need then to do the RC5011 automatic trust anchor dance that we have seen before. It's maybe one of the easiest way to get the new trust anchor, but it might not be an option if you are on an enterprise Linux that still ships with bind 9.8 or bind 9.9. You can do manual configuration in that case. If RC5011 fails and you don't install the new version of bind, you can go into the named.conf, the bind's configuration file, and put in a manage keys block, just like shown here on the slide, and you find that block on the link that is on the slide on the bottom. You can just copy and paste that in your configuration, check the configuration with named.conf, then reload, and you are done. You have the new trust anchor. No rocket science. The latest bind versions, they send key rollover telemetry to the operators of the root zone. Every 24 hours, they send a request for _TA dash and then the number of the trust anchor. So it would be _TA dash 19036 for the current key signing key, and then the trust anchor zone, which is just a dot for the root zone, record type null. And the DNS server doesn't expect any answer from this. It's just a way to tell the operator of the root zone which trust anchor is currently configured on the resolver. And that helps the operator of the root zone to get some feeling how good the automatic trust anchor rollover is working in the internet. This is a relatively new idea to have this feedback channel, and it has been standardized in an RFC just in April this year. So because of that, it's not implemented widely, and it's only in the latest bind versions and not in any of the other name servers as far as we know. So that was bind. With Unbound. Unbound stores the key signing key trust anchor in a file called root.k, and that file is usually found in the Unbound's configuration directory, for example, etc unbound root.k, but that can be changed in the configuration file. So best is you look at your configuration file and see where the configuration is pointing to. And that file contains the trust anchor information. It contains the DNS key, the key signing key public part from the root. And you see an example here on the slide how it looks like. It's also the ID 19036. Unbound comes with a tool called Unbound Anchor, and that tool will fetch the current root DNS trust anchor from the IANA's website. It uses HTTPS, so it's TLS secured, and it will then automatically update the root.key file. Most Linux distributions execute that tool during the startup script. So if you restart your Unbound or reboot your server between 11th of July and 11th of October this year, chances are very high that Unbound Anchor will just download the new trust anchor for you and configure everything correct. You just have to look into the root.keys file, make sure that the new trust anchor is then there. If you don't restart and if you don't use Unbound Anchor, then Unbound will try to update the trust anchor using the RC5011 protocol. And if you update to the latest Unbound 1.6.2, it also has the new trust anchor built in. So if you update your software, that's a third way to get the new trust anchor. And this is how the root.key file might look after 11th of July. It will then contain both trust anchors, the old one and the new one. So as with bind, it's also possible to configure the trust anchor manually in unbound.conf. The easiest way is to use the SHA-256 hash of the new key signing key. You find the new hash of the key signing key already on the data.iana.org/root-anchors website. And here on the slide, we show how the configuration statement is or how it is written in the unbound.conf file. You can copy the hash directly from that website. Also, the latest Unbound versions, they contain a new feature which allows someone from the outside, possibly the DNS administrator, to request a list of all the trust anchors that are configured in that Unbound instance. For that, you ask the Unbound for trustanchor.unbound in the chaos class for a TXT record. So this is very similar to version.bind that you can do in with bind servers. And the response will be the domain for the trust anchor, which is dot for the root zone here in this case, and then the key ID of each trust anchor there. It's possible to integrate that query into a monitoring system to track the key signing key and the trust anchor rolling. And now we look on at Windows, the Windows server. So the current trust anchor in a Windows DNS server, and that can be Windows 2012 or 2016, can be seen from the DNS management console. If you open the management console for your DNS server, go to trust points, and then select the root folder, you will see one or more DS records in there. And if you open that, you see there the key tag, and you can compare that key tag with the current key signing key and the new key signing key. So this screenshot shows the current key signing key, and later on, after July 11th, it should also show the new one. The Windows DNS server will also try to update this trust anchor with RC5011. There is a command, DNSCMD/retrieve root trust anchors, that will do something very similar to Unbound Anchor. It will load the current root DNS trust anchor from the IANA website, also TLS secured HTTPS, and it will update the trust anchor in the Windows DNS configuration. If you don't have DNSSEC validation enabled on your resolver and you execute this command, it will also enable DNSSEC validation. Just make sure that this is what you want. You also can configure a trust anchor manually. For that, you select trust point, add, then DNS key, or you can also choose DS for the hash. We show here how to do it with DNS key. It will show a new dialog where you can put in the name for the zone for the new trust anchor. The name will be just a dot for the root zone. And then in the public key field, you copy and paste the base64 encoded raw key material into that field. Important here, it must be without spaces and without breaks. So you can copy and paste from the slide, but make sure that you remove all the spaces and breaks that might be in there. So, and with that, we conclude this webinar. Here we have a page with additional informational resources. We have the RCs. There is an automated trust anchor update test bed from ICANN. It's automated-ksk-test.research.icann.org. And you can sign up there for free, and it will do a simulated key signing key rollover in 30 days. It starts every week, a new test. So you can just sign in there and configure your DNS resolver to use that test bed, and it is a good test to verify that RC 5011 Trust Anchor update works for you. Also, there is the Get Trust Anchor tool on GitHub, which can be used to fetch the Trust Anchor from the IANA webpage and print it out on the screen. That's a good way to get the new Trust Anchors. There is a report on the creation of the new DNS root key signing key if you're interested in that. It has all the signatures of all the people involved there scanned in. There is the RC on the telemetry signaling, and there is a script on GitHub from Shane Kerr. Shane, we had him on this webinar last year on the Yeti project. He has written a small script that builds Trust Anchor telemetry for Unbound. And ICANN has a key signing key roll overview with a lot of information, and also IC has published a blog post on the very same topic on the key signing key rollover with bind 9. So before we go to the question and answer part, we will have more Men&Mice DNS training. There is the DNS and Bind hands-on class in Boston, Massachusetts in August this year, and in September we will be in Zurich. And there's also be the extended, the 5-day class, Introduction and Advanced DNS and Bind topics, also in Boston and in Zurich. So you can either sign on for the 3-day course or the whole 5-day, whole week course. And the next one in Germany will be in December, and that will be the DNSSEC and DANE workshop. The webinar series takes a summer break now. We will be back in August. We haven't decided on the topic for the next webinar. We have a lot of ideas, so we are not out of ideas. But if you have some recommendations, some topics you would like us to explain or talk about on this webinar, please let us know. Send us a message on Twitter or email, and we will collect that all and put that into our pool of good ideas for this webinar series. So, do we have questions?
Well, Carsten, for anyone on this webinar, you can submit your questions through the GoToMeeting portal. But Carsten, maybe I have an idea for a webinar in November.
Okay.
You can maybe explain in November, like, why the internet crashed during this rollover.
The problem is, without internet, we cannot do the webinars.
That is correct. That will be a challenge. But
we can invite people to Iceland.
Yes. No, but
if the plane fly.
Yeah, but still, yeah. But still, I'm thinking like this key rollover. If you just look at bare facts, like there are surveys showing how, what version of bind servers and other servers users are used out on the internet. So obviously, people will still be running out-of-date servers and stuff like that. Do you foresee problems, and then like what effect do you expect, or what do you expect happening after this rollover?
Yeah, my expectation is that people that run outdated old versions of a DNS resolver, they probably don't have DNSSEC enabled, and all the DNSSEC enabled resolvers that you operate today that are compatible with the DNSSEC in the internet, they have already RC 5011 protocol baked in. So if DNSSEC is enabled, it will probably an almost up-to-date resolver that will probably work. What can go wrong? I haven't really talked about that in the webinar, is that if you operate a resolver in an environment, for example, where the hard disk is full, the resolver will just work fine, but it will not be able to store the new trust anchor. It will fetch the new trust anchor and then will barf and cannot store the new trust anchor. It will never do. And it will probably use that trust anchor in memory, but then when the machine is rebooted, boom, it will not work anymore. That can happen. Also, it could happen that the directory where the process wants to store the new trust anchor is has permissions that don't allow the process to write to the file. I've seen that in some installations. That might be one way where the trust anchor update might not work. And also, if you install a new DNS server from an installation medium that is old, like you use an old Red Hat 7 installation medium, after October, that will still come with the old trust anchor. And there's no way that the DNS server will do the RC5011 because the old trust anchor is already gone. There's no way to automatically create trust. So if you install a new operating system and a new server after October 11, you always need to update the trust anchor manually, unless you use the very latest version of Unbound and Bind.
Very good. So I don't see any other questions, Carsten. Well, unless these questions show up, I think we can put an end to the webinar as of now. But this will be an exciting time. I guess we all have to keep our fingers crossed and hope the rollover works as planned.
Yes, and as a last resort, there's support@men&mice.com. We are here to help.
Exactly. And I see some of the attendees joined the webinar after we started, and the webinar, the recording of the webinar will be available through our website within a few days, and you will probably get a notification from us on that subject. So thank you, Carsten, for today's presentation, and thank you all for attending, and hope to see you soon.
Thank you for being the host.
Thank you.
Bye for now.
Bye for now.